Hey, what's up, my chem peeps? What in the heck are we gonna do in this video? More Lewis structures. We're gonna construct electron dot formulas to illustrate covalent bonds. But in this video, let's break it down a little differently. We're gonna talk about how to determine what's called formal charge for any element in a Lewis structure. And two, we're going to use formal charge to determine the most likely representation of a molecule using Lewis structures. Alright, so before we really dive into this video, I want you to take a look at the image on your screen that you've also got in your notes. It represents 3 possible Lewis structures for the cyanide ion. And notice that each Lewis structure is a valid but different structure. Each of them show the elements following the octet rule. So how do we decide which of those structures is the best? And that's where formal charge in this video comes into play. Alright, so formal charge is the charge assigned to an atom in a molecule, assuming that its electrons in a chemical bond are shared equally between atoms, regardless of relative electronegativity. Now, importantly, note that this is just a fictitious charge. We're talking about covalent compounds. We don't have ions here, but we just use formal charge to help us figure out which Lewis structure is more correct. So keep that in mind. FC, formal charge, fictitious charge, but still important. All right, so the first thing you want to be able to do in this video then is figure out what the formal charge is, or how to calculate the formal charge of an atom in a molecule. And it's calculated using the formula that you see on your screen and that's in your notes. So to determine the formal charge, you would just take the number of valence electrons that a neutral atom of that element would have, then look at the Lewis structure and subtract the number of lone electrons around that atom in the Lewis structure and half the bonding electrons. That's how you calculate formal charge. So let's come back to this thrilling image that's in your notes on your screen to practice calculating formal charge for each of the atoms in each of the Lewis structures, possible Lewis structures for the cyanide ion. Take a look at oxygen in this first Lewis structure for the cyanide ion. Oxygen has 6 valence electrons. In this structure, it has 6 lone electrons, so I'm going to subtract that from 6. And there are 2 electrons that are shared in this bond. So I'm going to subtract half that number of electrons, or 1. 6 minus 6 minus 1, -1 would be the formal charge for oxygen in this representation, in this Lewis structure of the cyanide ion. Carbon has 4 valence electrons. No lone electrons in this Lewis structure representation, and there are 8 bonded electrons around it. So I subtract lone electrons, which are 0, and half the bonded electrons, which are 4. 4 minus 0 minus 4, 0. Nitrogen, notice that it has 5 valence electrons to start. Subtract the 2 non-bonding electrons and half the bonding electrons. 5 minus 2 minus 3, 0. Take a moment, pause the vid, look at the other 2 possible Lewis structures for the cyanide ion, and notice how the formal charges are calculated in each example. All right, great, Boylan, I know how to calculate formal charge. I can subtract. Awesome. How are we going to use formal charge to help us determine which Lewis structure is best? Use the following criteria. First, the sum of all formal charges in a neutral molecule must equal 0. In a charged ion, the sum of all the formal charges must equal the charge on the ion itself. Second thing to look for, better structures have more atoms in the molecule with a formal charge of 0. 3. When not all formal charges are equal to 0, better structures have more formal charges that are closer to 0. So if you can't get them all to 0, the better one is going to have more of them at 0. And finally, better structures have the negative formal charge on the more electronegative atom. So come back to this thrilling image of your 3 different cyanide ions and look at the formal charges for each of the atoms in each of the Lewis structures. Hopefully you can identify that Lewis structure C is out as an option. Using that criteria that I just discussed, notice that it has oxygen with a formal charge of +1, carbon with a formal charge of 0, and nitrogen with a formal charge of -2. 2 of the atoms in this molecule do not have a formal charge of 0, whereas these 2 Lewis structures, they do. So these 2 are better. As I decide between the final 2 Lewis structures, notice that on Lewis structure A, the negative formal charge is on oxygen, where in B, the negative formal charge is on nitrogen. Of the two, oxygen is more electronegative, which means that B is out, and that Lewis structure A is actually the best representation for the cyanide ion. Again, even though not all of the atoms in the molecule have a formal charge of 0, most of them do, or 2 out of the 3, and the one that doesn't is a negative formal charge on the more electronegative atom. Additionally, the sum of the formal charges is -1, which is the charge of our cyanide ion. So, we're just adding another layer to the Lewis structure fun. If you're going to use formal charge, just draw the Lewis structure that you normally would draw. Then, assign formal charges as we just discussed. Figure out the number of valence electrons in each atom, subtract from that the number of lone electrons, and half the number of bonded electrons. And then finally, just move electron pairs around. It takes a little bit of practice, but it becomes fairly easy. Generally, it's a good idea to move electron pairs from atoms with negative formal charge towards atoms with positive formal charges. Again, our goal is to get as many atoms, if not all of them, to have formal charges of 0. And moving electron pairs from atoms with negative formal charge to positive formal charge will do that. Remember that elements in the second period maintain the octet rule. Always! Rule followers! And then remember for elements in the 3rd through 7th periods, they can bring in electron pairs to reduce the formal charge to 0, even if it gets an expanded octet. As an example, take a look at 2 potential Lewis structures for the sulfuric acid molecule. If you follow the rules as you normally would for drawing Lewis structures, you'll probably end up with the Lewis structure that you see on the left. Assigning formal charges to the atoms in that molecule, though, will give you a couple of oxygens with a formal charge of -1 and a sulfur with a formal charge of +2. Drawing in some of those lone pairs of electrons from the atoms with negative formal charge, creating extra bonds, gets all of the atoms in the molecule to a formal charge of 0, making the structure on your right a better representation of the sulfuric acid molecule. Whew.